Algebra 2. This is notes for 6.2. All right, we're dealing with these exponential functions. And so this first one has to do with the population type problems we had last time. So we had our general equation for an exponential function, y equals a times b to the power of x. But then for the population type problems, we replace the b with either 1 plus r or 1 minus r. So that could show a growth rate, r being the growth rate or the decay rate. This question, though, we're using the same formula, but it's a different kind of question. Before, they would say, like, it's growing so much per year, you start out with so many people, and then how many people will there be after so many years? Well, this question is a little different. The population of a small town was 8,000. It's increasing at a rate of 2.5% per year. Rewrite an exponential growth function to find the monthly growth rate. Shoot, I don't have my notes with me right now, so hold on one second. I can pull them up. My bad. So we're going to start out with y equals our initial value, 8,000, times 1 plus our r, 2.5%, move the decimal 2 places to the left, so 0.025. And instead of x, we used a t for time, and actually up here on that one I should have done that. So they replaced the x variable to a t just so it could be in time. Now we're going to do something. The rest here is just a little bit of fancy algebra. So instead of writing t, we want the growth rate. So we're going to, we want the monthly growth rate. Oh, and right now, 1 plus 0.025 obviously is 1.025. Instead of writing 1t, I'm going to write 1t as 12 over 12t. Why 12? Because there's 12 months in a year. So just roll with me on this one. Now, this is where the fancy algebra comes in. 1.025. Now I'm going to separate that 12 over 12 exponent inside the parentheses 1 over 12, and then the 12 over 1 on the outside. Because as you guys know, our exponent rules, power to a power, you multiply the powers, and this is still 1/12 times 12 is still 1. So it's the same problem, we're just writing it in a different form. Now what I'm going to do is I'm going to take my calculator and I'm going to figure out what is 1.025 to the power of 1/12. And that comes out to be 1.00206. So there we are. Now I'm going to take this part again and I'm going to separate it back out into the 1 plus so I can have the r value. 8,000. Instead of 1.00206, that's 1 plus 0.00206. And so now this is the r value. That tells me that r is 0.00206, which then I'm going to go back and put it back to being a percentage. So I move the decimal 2 places to the right. 0.206% is our monthly growth rate, growth factor. growth rate, growth factor. I think you can call it either of those. This problem called it rate, so let's stick with rate. All right, so now you have one to do. And did you notice this whole time the 8,000 didn't even matter? It never got computed. We were just trying to figure out that R value. And so they don't even give it to you in this one. All you know is the percent rate, and that's all you need to know. But this time they're asking you the quarterly rate. Quarterly would be 4 times a year. So instead of using 12 over 12, you're going to want to use 4 over 4 rather than 12 over 12. So please pause the video, try this problem, and then come back to check your work. All right, we would have 1 plus 0.018 to the power of 4 over 4t, and 1.018. Now I'm going to separate it to the 1/4 to the 4t, and now I'm going to put this guy in my calculator, and I get 1.00447. And now I separate it into the 1 plus 0.00447. And now this value is my R value. So our growth rate for this problem would be technically 0.447%. So I made the decimal back into a percent. All right. Another formula we are going to use a lot of is the compound interest formula. It's over here, listed over here, and so it has to do with investing money. When interest is paid monthly, the interest earned after the first month becomes part of the new principal for the second month, and so on. Interest is earned on interest already earned. This is compound interest. And you can see the same basic, you've got your A value, which now we're just calling it a P. We've got our parentheses, 1 plus R, but now it's R over N. And then instead of just a T, our exponent is N times T. So in this, N is the number of compounding periods. So if the bank tells you this is compounded monthly, then N would be equal to 12. Or compounded annually, N would be equal to 1, etc. That's how often they're figuring out the interest that they're going to pay you. And P is the principal, the initial value, what you're depositing or investing. So that's what we use for this problem here. Tamira invests $5,000 in an account that pays 4% annual interest. How much will there be in the account after 3 years if we're compounded annually, semi-annually, quarterly, or monthly? So the part of the formula that's different for these is the N. For annually, N is equal to 1. Semi-annually, N is equal to 2. Quarterly, N is equal to 4. And monthly, N is equal to 12. And the rest of this, we've got our P value is 5,000. Our R is 0.04, moving the decimal 2 places to the left. And T then is equal to 3. So they're essentially asking us to do this problem 4 different times with 4 different N values. So let's get to it. Our formula, A is equal to P times 1 plus R over N to the power of N times T. So let's do when N is equal to 1. A would be equal to our principal, 5,000, times 1 plus our R is 0.04 over N is 1 to the power of 1 times 3, N times 3. Now I'm going to go through and we'll do the calculator in a minute. Let's do our formula part, writing down our formula. 5,000 times 1 plus 0.04 is the R over N. Now N is 2 to the power of N times T, so 2 times 3. And now when N is 4, A is equal to 5,000 times 1 plus 0.04 for the rate over 4 for the N to the power of N times T, 4 times 3. And finally, A is equal to 5,000, 1 plus 0.04 over 4 to the power of, I used 4 again. This time N is 12, so 0.4 over 12 to the power of 12 times 3. So now in your calculators, what you want to do is, if your exponent is made up of two numbers being multiplied, added, or whatever, you would have to put parentheses around this in your calculator. Or you could just go 4 times 3 is 12, which seems just as easy. All right, so please make sure that you can get these numbers with your calculator. That's the important part. Can you use your calculator to do this calculation? So on this one, compounded annually, we get $5,624.32. And then when we are compounding semi-annually, $5,630.81. And then compounded quarterly, we get $5,634.13. And finally, when it's compounded monthly, we get $5,636.36. So look at they're all 5,000, but look at the numbers: 624, 630, 634, 636. So every time as you increase the number of times it's compounded, the more money you're getting. So please pause the video and try this problem, and then come back to check your work. My main concern for now, remember, is being able to not just plug the numbers in, but get the answer with your calculator, using your calculator properly. So this time they want you to, you're investing $3,000, 3% annual interest, compounded monthly, so N is equal to 12. What is the value of the account after 10 years? What is the value of the account after 100 years? Again, please pause the video and come back to check. So after 10 years, A is equal to, we are investing 3,000. 1 plus our percent is 3%, so 0.03